we're going to start with circuit variables. In order to understand circuit variables, we've got to start from the circuits, of course. What's the relation between the variables and the circuits? So we've got to mention a bit circuits and what is those circuits in practice and theory. So I'm talking about this frame. And then the basic operations that we do, or basic subjects that we will be examining, is analysis and synthesis. So start from the circuit variables. It says, in practice, electrical variables are measured on circuits in lab. Electrical variable is something that we measure in the circuits lab. In theory, electrical variables are calculated on circuits on paper. So practice and theory mentions the variables, and we measure them in practice and we calculate them on paper. These variables, let's say the name of the variables at the beginning, which is current and voltage. These are the fundamental variables in circuit theory. Let's go in a bit details with the circuits in practice and theory. In practice, we've got equipments. Equipments have got sub-circuits. Circuits composed of circuits. Circuits are composed of components. This is what we've got in practice as circuits. Setting a circuit, connect components together. That's in practice. In theory, the corresponding elements for the equipment is systems. We call them systems. So systems has got subsystems, subsystems composed of circuits. Circuits has ideal elements. Setting a circuit, connect the ideal elements together. Now when you compare practice and theory, you see some of the wordings are different. It says here in practice component, and it says here ideal circuit elements. Before we see the difference between those two, let's define what system is. System is for a purpose, put the parts together. So there should be an aim or should be a purpose of put the elements together. That aim determines the system. So conclusion is that when you connect the elements randomly, it is not a system. There should be a purpose. For this purpose, you are collecting elements or put them together. Then it becomes a system. So in this theory, we use ideal elements. The reason is this: ideal elements is not the same as the components, at the beginning at least. Ideal elements, the elements for which the mathematical representation is simple. Why we need that? Because the mathematical relation for the elements should be as simple as possible at the beginning. When put them together, when put those elements together, so represent those circuits in mathematics would be simpler. Therefore, we are introducing ideal circuit elements in theory. So the question is, what is the relation of ideal circuit elements and the components in practice? The answer to that question, for each component in practice, there is a composition of the ideal circuit elements which represent this component. So let's say the equivalent circuit to a component in practice is composed of the ideal elements. So we can represent each practice component with the ideal circuit elements. When you replace these components with these ideal elements, that means you are representing a practical circuit in theory which includes ideal elements in it. So in practice, what a circuit does is determined by measuring electrical quantities in lab. When you say what a circuit does, that is the purpose of the circuit. As you remember that we said each system must have a purpose, what must be an aim. So this aim is what it does. So we can understand whether it does something about the aim. We can determine it by measuring the electrical quantities in lab. These electrical quantities, once again, is current and voltage. In theory, what a circuit does, that means the aim or the purpose of the circuit, is determined by calculating electrical variables on a mathematical model for a given circuit. So the aim is important in the system. So let's come to the next frame. So we mentioned about the circuits, and then we explained the relation between these circuits and the circuit variables. So what we do with these circuits, two main actions that we could do on circuits. One of them is analysis, the other one is the synthesis. Analysis and synthesis are also the main concepts of engineering. In practice, what is analysis? Measuring voltages and currents of components in the given circuit. So that means in order to analyze a circuit, first of all, the circuit should be given to you, and then you're going to measure all the elements, current and voltages. Then that means you analyze the circuit. Why we do that? That is related to the definition of the systems, because there is a purpose of this circuit. So in order to understand this purpose, we've got to measure what it does in the lab. So we're going to measure current and voltage of an element. So this is the general form of the purpose measuring. What I mean by saying purpose measuring, if you consider a circuit, there is an input and there is an output. Input is the source. That means you've got a signal, a variable or electrical quantity as an input. So you are transferring this electrical quantity to another quantity, which is output. So that output is our aim. We are expecting an output. This is what the circuit does. So in this situation, we are going to check whether this circuit works properly or not. Then you're going to measure the output. So this analysis is the generalization of this output measuring. We are considering each element could be an output of a circuit. So we are measuring all the elements, current and voltages. This is what we do in practice. In order to explain this situation, that circuit, we could give you an example in practice. Consider the TV set. TV set is a system. This system has got an input and has got an output. What is the input of this system? Is the electromagnetic signal in the air. This signal covers all the TV channels information. That's the input. Comes to the antenna, which is the part of the TV set. The output of the TV set is the electrical signals just before the screen. Screen is the output. The signal coming to the signal is the output of our circuit. So that output signal is important because what it does is this. We cannot see the channels information which is available in the air. We can't see it. But we need an equipment which transfers this channel's information to our visible signal. That means that is TV. So you understand the input and output of a circuit. Output also is the purpose of the circuit or the function of the circuit, we might say so. So we talked about practice. So when we come to theory, what we are going to do, calculating voltages and currents of the components in the given circuit is called the analysis. So in here we are measuring, but in here we are calculating. In theory we are calculating. Whatever circuit in practice, we are going to transfer this circuit to the ideal elements connected circuit in theory, and then we are going to measure these elements, we are going to calculate these elements, all the elements, current and voltages. That means we have done the analysis of the given circuit. The another concepts that we use in electrical engineering is the synthesis, or in general in engineering, not electrical engineering only. So synthesis, finding the elements types and their connections to each other, that is circuit, which transfers a known input to a known output, that is engineering. So consider the TV set now. If somebody says that I have got available TV channels signal, which is an electromagnetic signal, transfer that signal to another signal which helps the human to see it, then you are defining a TV set. So when you define a TV set like that, this is at the same time, this definition includes the input and output of your circuit, of your TV set. So you're going to design a TV set means you're going to choose the right or proper elements and connect them together. This means a circuit. These circuits transfer the given input to a given output. So that is the TV set. So we're designing that TV set. So we call this is synthesis. From time to time we might call it a design. This synthesis cannot be done in lab. So synthesis is something that should be done mathematically in theory. Why is that? If you go to lab and if we say that all the elements are available on the boards and choose whichever element you like and connect them whichever way you like and set up a TV set for me in the lab. If randomly you choose these elements and connect them randomly, you cannot get a TV set in the lab. So that means you could try many times these random connections, random selections of the elements, but you cannot reach the TV set within your lifetime period. So that means we cannot do the analysis in the lab, synthesis in the lab. Sorry, we could do the analysis in the lab. So what we are going to do in terms of synthesis in the lab, what we calculated in theory, find the element types and their connections. That means theoretical synthesis has completed on paper. So you could then go to the lab, use the same elements that you found in theory and connect them to each other as you found in theory in the lab, and you can test your design that you found in the synthesis in theory. You're going to do this test in the lab. So this is the relation between synthesis business and the synthesis in lab or in practice. So if you look at the whole system now, in order to talk about the electrical variables, we've got to mention the circuits in theory and in practice. And the circuits, we've got two concepts that we use: analysis and synthesis. In the analysis and synthesis, we mentioned about the variables that we are going to measure or what that we are going to calculate. These are the electrical variables. Fundamental electrical variables are the current and voltages. So we could see this next frame that we are going to explain. So in order to mention directly the current and voltage, we made an introduction starting from the circuit and the operations that we do on circuits or subjects that we do with the circuits analysis and synthesis. And then we will be explaining these fundamental variables and the other variables next step.